Dear viewers, this video is presented to you by Rajiv Institute of Technology, Hassan, Department of VLSI Design and Technology. I am Ambika K, working as Assistant Professor. In the section of Digital Logic Circuits Lab, in this video, you are going to learn the theory and the demonstration of the flip-flop, master-slave JK flip-flop using the IC 7476. Let us first learn the pin diagram description of the IC 7476. Basically, 7476, it consists of two JK flip-flops. So it consists of two master-slave JK flip-flops. The master-slave JK flip-flop is a unique class of a flip-flop in which we can find two sections. The first section is acting as a master flip-flop and the second section is acting as slave flip-flop. As the name itself depicts, master flip-flop is one which is going to give the orders, whereas slave flip-flop is the one which is going to receive those orders. Here orders are nothing but the states of the flip-flops. So master flip-flop is going to dictate the states and slave flip-flop is going to present those states to the outside environment. 7476 IC, it consists of 16 pins, and along with the inputs, along with the synchronous inputs J1 and K1, 7476 also consists of other kind of input also, which are called as direct inputs. So preset and clear, these are considered to be the direct inputs. Preset is used to set the flip-flop, whereas clear input is used to clear the contents of flip-flop. And each JK flip-flop is going to have its own clock, that is clock 1 for the first flip-flop and clock 2 for the second flip-flop. And each flip-flop is going to have its own outputs, Q1 bar for the first flip-flop, Q2 bar for the second JK flip-flop. Now with the help of the JK flip-flop, the master-slave flip-flop has to be realized. This is the function table of the 7476 flip-flop. For the normal operation, preset and clear inputs of 7476, it should be activated high, because preset and clear inputs are active low signals. Active low signals means if logic 0 is provided as an input, those signals will become active. If logic 1 is given to them, they will become inactive. So for normal operation, their values should be high. For other operation, their values should be kept at low. So the first of three rows of the function table is going to depict the other operations of the JK flip-flop. The fourth row of a flip-flop is going to highlight the normal operation of a JK flip-flop. So both preset and clear, they have kept at their high position. Then clock signal is applied and JK value is LL. LL means 00. Then the outputs Q and Q bar, we won't find any changes in their next state. Whatever the present state is there, that will be carried down to the next state also. The next row where J is equal to 1 and K is equal to 0. For J is equal to 1 and K is equal to 0, the next state is going to be set, that is Q is 1 and Q bar is 0. The next combination of the inputs is J is L and K is 1, means J is 0 and K is 1. If K is equal to 1, the JK flip-flop is going to reset. Reset means Q value will be equal to 0. The last combination of JK flip-flop is 1, 1. When both the inputs are 1, the flip-flop is going to toggle. This is the very unique condition of a JK flip-flop. Means there will be always from 0 to 1, 1 to 0, the states are going to be repeated. So this is the toggling state of a JK flip-flop. So this is how the master-slave JK flip-flop that is present in the IC 7476 is going to work. the circuit for master slave JK flip-flop is rigged up here using the IC 7476. 7476, it consists of two JK flip-flops. So it is called as a dual JK flip-flop. So let us switch on the IC trainer kit. This master slave JK flip-flop, it consists of two inputs. One of the input is J, another input is K. So J and K. So J refers to the set input and K refers to the reset input. So these are called as synchronous inputs. Apart from these synchronous inputs, 7476 IC is also having direct inputs. They are, one is preset, another one is clear. So these are active low signals. For the normal operation, their values should be kept at high. So they are active low signals. Now let us check the truth table of the JK flip-flop for the realization of master slave JK flip-flop. The first combination is 0 0. J is equal to 0, K is equal to 0. Let us apply the clock pulse. When J is equal to 0, K is equal to 0, the flip-flop should not change its state. It has to retain the same state as its next state. As long as the clock pulses are applied, we can observe the output is not changing. Now let us go for the next combination, that is J is equal to 0 and K is equal to 1. Apply the clock pulse. So for J is equal to 0 and K is equal to 1, the JK flip-flop should reset. Reset means Q should be equal to 0 and Q bar should be equal to 1. Now let us go for the next state. Next input combination of J and K. J is equal to 1 and K is equal to 0. Apply the clock pulse. For this combination of inputs, the JK flip-flop should set. Set means Q should be equal to 0 and Q bar should be equal to 1. Now the last combination, wherein we have to give both J and K as equal to 1, and this is the unique condition that is available in JK flip-flop. When both J and K, when both are equal to 1, the flip-flop should toggle. Upon the application of clock pulse, it should change its state from 0 to 1, 1 to 0. We can observe that. As long as the clock pulses are applied, the flip-flop is changing from set state to reset state and reset state to set state. So this is the realization of master slave JK flip-flop using the IC 7476.